In this video, we're going to look at Cambridge International AS and A-Level Mathematics 9709, Probability and Statistics 1, Paper 5-1 from May-June 2025. Let's start with question 1. The masses of the bags of rice made by a company are normally distributed with mean mu kilograms and standard deviation 0.14 kilograms. The probability that the mass of a randomly chosen bag of this rice is less than 1.48 kilograms is 0.22. Find the value of mu. To find mu, we can use the formula Z is equal to x minus mu over standard deviation. The question tells us that standard deviation is 0.14, so I can make a note of this over here. Standard deviation is equal to 0.14. It tells us that the rice is less than 1.48 kilograms. That is our x value. You can say x is equal to 1.48. The probability is 0.22. When you have a probability smaller than 0.5, we know that z is going to be smaller than 0. Now we have the standard deviation and the value for x. To find mu, we need our value for z. To find this value, we can use our normal distribution table. So we're going to say 1 minus 0.22 is equal to 0.78. This is the value we're going to look for in our table. Now, we don't get 0.78 directly in our table, but the closest we can find is 0.7794. Always look for the number that is smaller than the value we're looking for. For this value, we can see that z is going to be 0.7. I can say 0.7. In this column, we have another 7, so 0.77. We need to add 6 to this value. So if we add 6, we add 2 to z, 0.772. But remember that z is negative. So our z value, z, is equal to negative 0.772. Now that we have these values, we can put them in the formula. So I can say negative 0.772 is equal to x 1.48 minus mu over standard deviation 0.14. Now we can rearrange this equation to solve for mu. So let's multiply both sides by 0.14. So I'm going to have negative 0.772 multiplied by 0.14 is equal to 1.48 minus mu. To solve for mu, I need this value to be positive. So let's move it to the left-hand side. And I can say mu is equal to, on the right, I have 1.48. And I'm going to move all of this to the right as well. So I can say plus 0.772 multiplied by 0.14. Now I can put this into my calculator. 1.48 plus 0.772 multiplied by 0.14 is equal to 1.588. All of the values we've been given are to 2 decimal places. So we need to leave our value for mu to 2 decimal places. And we can see that mu is equal to 1.59. Question 2a says find the number of arrangements of the 8 letters in the word kangaroo in which the 2 A's are together and the 2 O's are not together. Now, it's easier to find arrangements when letters are together than when they're not. So in this case, we're going to find the number of arrangements when only the two A's are together, and then we can subtract the arrangements when both the A's and the O's are together. And this will leave us with the number of arrangements where the O's are not together. A good place to start is to make a note of our repeated letters. So in our word, we have two A's, we have two O's, and then we have K, N, G, and R. Let's start with the number of arrangements when only the two A's are together. So I can say A and A. Let's put that into a bracket. I still have 6 letters. 1, 2, 3, 4, 5, 6. I count the bracket as one element, which means now I have 7 letters. I can say 7 factorial. I have 2 repeated letters in my bracket, so I can leave those as they are. In these 6, I'm going to have 2 O's. So we divide by 2 factorial. Now I can put this into my calculator. 7 factorial divided by 2 factorial is equal to 2,520. This is the number of arrangements when only the A's are together. Now let's find the arrangements when the A's are together and the O's are together. So I have my 2 A's. Let's put that into a bracket. I have 2 O's. Let's put that into a bracket. And I still have 4 letters. We count the bracket as 1. So now I have 1, 2, 3, 4, 5, 6 elements. So I have 6 factorial. I don't have any repeated letters here. So I need to focus on 6 factorial. Take my calculator. 6 factorial is equal to 720. If there are 720 arrangements where the A's and the O's are together, and 2,520 when only the A's are together, I can subtract 720 from 2,520. So 2,520 minus 720. Now I can take my calculator. 2,520 minus 720 is equal to 1,800. This is the number of arrangements where the O's are not together. Now let's move on to part B. A fair 8-sided dice with faces labeled KANGAROO. The dice is rolled repeatedly. Find the probability that fewer than 6 rolls of this dice are required to obtain an A. The dice is rolled repeatedly. There is no set number of rolls. So this shows us that we are working with geometric distribution. We need to find the probability of fewer than 6 rolls. So we're going to use the formula, the probability that X is smaller than or equal to R is equal to 1 minus Q with an exponent of R. This formula is not in your formula sheet, so make sure to learn it. To find Q, we need P, and P is the probability of rolling an A. Out of our 8 letters, we have 2 A's. So we can say the probability of A must be 2 out of 8. Let's simplify, and we get 1 over 4. Q is the probability of not rolling an A. So we can see that Q must be 1 minus 1 over 4, which gives us 3 over 4. The formula says the probability that X is smaller than or equal to R. Be very careful with this sign. We are looking for the probability that X is fewer than 6, smaller than 6, which means that X has to be smaller than or equal to 5. So this is our R value. So now I can say probability that X is smaller than or equal to 5 must be equal to 1 minus R 3 over 4 with an exponent of 5. Now I can take my calculator. 1 minus, open a bracket, 3 over 4, close the bracket with an exponent of 5 is equal to, let's make it a decimal, 0,7626, round off to 3 decimal places. We're going to get an answer of 0,763. Part C says find the probability that the second A is obtained on the 6th roll of the dice. Statistics is realistic, so a good place to start is to make some notes of what we know. The second A is obtained on the 6th roll. So let's say we have our first roll, second roll, third roll, fourth roll, fifth roll, and sixth roll. The second A is obtained on the 6th roll. So that will be an A. If it is the second A, that means that in the first 5 rolls, we will get 1 A and 4 values that are not A. The probability of A is 1 over 4. So the probability of not rolling an A is 3 over 4. Now with this, we can draw up our equation. Let's start with our second A. So the probability of 1 over 4. And we have 1A in our first 5 rolls. We can say and 1 over 4. And 4 values that are not A. We say 3 over 4 multiplied by itself 4 times. Let's give this an exponent of 4. But we do not know when the A occurred in the first 5 rolls. Was it first, second, third, fourth, or fifth? So to account for this, we multiply by 5. Now I can take my calculator and I can say 1 over 4 multiplied by 1 over 4 multiplied by 3 over 4 with an exponent of 4 multiplied by 5 is equal to 405 over 4,096. 405 over 4,096. This is the probability that the second A was rolled on the 6th turn. Question 3 says, last Sunday, teams of runners took part in a charity event. The times taken in seconds to run 50 meters was recorded, correct to 1 decimal place for each runner. The times recorded for 11 runners for each of the gulls and the herons are shown in the table below. Part A says draw a back-to-back stem and leaf diagram to represent this information with gulls on the left-hand side. Now, in order to draw a stem and leaf diagram, we need our values to be in ascending order from smallest to biggest. These have been given to us for the gulls, but not for the herons. So let's start by rearranging our values. The lowest one is 8,1. We can say 8,1. Then we have 8.3 and 8,5. Take out those two. Then we have an 8,7. Take out that one. And now we can look at our values for 9. We have 9,2, 9,3. Let's take out these two. 9,5, 9,7. We have 2 9,9s. So that's 1, 9,9, and then the highest value of 10,8. Let's tidy this up. Now we can draw a diagram. The question tells us to put the gulls on the left. So let's say the gulls are on the left and the herons are on the right. And now we can start with our stem. The gulls have got a smallest value of 7,9 and the highest value is 10,8. So let's write our stem as 7, 8, 9, and 10. And now we can fill in our leaves. We write our values in ascending order outwards from smallest to biggest. Let's start with the gulls. The gulls have a value of 7,9. I can put 9 over here. Then we have 8,2, 8,3, 8,6, 8,6 again, and 8,8. Then we have 9,2, 9,7, 9,8. For 10,0, we put a 0 into the leaf. Then we have 10,4. Let's do the same thing for the herons. We don't have any values that start with 7. So we have 8,1, 8,3, 5, and 7. For 9s, 9,2, 9,3, 9,5, 9,7, and 2 9,9s. And then for 10, 10,8. When drawing your diagram, don't forget about a key. A key allows a reader to understand what you're saying. So in this case, I'm going to say that 281 shows 8,2 for the gulls and 8,1 for the herons. Now we can move on to part B. Find the median and interquartile range of the times of the runners for the gulls. So let's look at our diagram. The median, Q2, sits directly in the middle of the data set. And the easiest way to find this is to consider the total number of values. We're working with 11 runners. So I'm going to say the position of Q2 is equal to the total number of runners plus 1 over 2. We have 11 runners. We say 11 plus 1 over 2. 11 plus 1 is 12, divided by 2 gives us 6. Q2 is the sixth value. 1, 2, 3, 4, 5, 6. This 8. So I can say that the median, Q2, is equal to 8,8. In order to find the interquartile range, I need Q1 and Q3. Q1 sits below Q2 and Q3 sits above it. When looking for these values, we do not consider the median. We had 11 runners, no longer considering the median, which means we now have 10. 5 on one side and 5 values on the other. So let's say to find Q1, I'm going to say 5 plus 1 over 2. 5 plus 1 is 6, divided by 2 gives us 3. So Q1 is the third value in the data set. 1, 2, 3. 8,3. So Q1 is equal to 8,3. To find Q3, we now count 3 places on the other side of the median. 1, 2, 3. So Q3 is equal to 9,8. To find the interquartile range, we simply subtract Q1 from Q3. So we can say 9,8 minus 8,3 is equal to 1,5. This is my interquartile range. Part C says two other teams of runners, the Eagles and the Swifts, also took part in the event. The recorded times in seconds for 20 runners from the Eagles and 30 runners from the Swifts are denoted by X and Y respectively. It is given that sigma X is equal to 175 and the mean of Y is 8,4. Find the mean of the times taken by all 50 runners. Let's start with the formula for the mean for all of the runners. So I'm going to say the mean of the runners for X and Y is equal to sigma X plus sigma Y all over the runners from the Eagles plus the runners from the Swifts. Let's say these are X and these are Y. The question tells us there are 20 runners from the Eagles and 30 from the Swifts, and the total is 50. So we know that nx plus ny is equal to 50. It also tells us that sigma x is 175. Sigma x is equal to 175. But to find the total mean, we still need sigma y. The question tells us that the mean of y is 8,4. I'm going to say the mean of y is equal to 8,4. But remember that the mean is sigma y over n. Y is the Swifts, and there are 30 runners. So we can say that 8,4 is equal to sigma y over 30. So to find sigma y, we multiply 8.4 by 30. You can say 8,4 multiplied by 30 is equal to 252. This is my value for sigma y, 252. Now I can make some space and I can fill my values into the formula. So I can say the total mean is equal to sigma x, 175, plus sigma y, 252, all over the total number of runners, 50. Take my calculator, 175 plus 252 divided by 50 is equal to 8,54. So the total mean is 8,54. It is given that sigma x squared is 1,823. It is also known that the standard deviation of the times taken by all 50 runners is 1,38 seconds. Part D says find the value of sigma y squared, correct to one decimal place. Now, please be careful. Sigma y squared is not the same as sigma y squared. But to find this value, sigma y squared, we can use the equation for standard deviation. So we can say standard deviation is equal to sigma x squared plus sigma y squared over runners for x, nx, plus runners for y, minus the estimated mean of x and y squared, all under a square root. This gives us the value of the standard deviation, but the question tells us that this is 1,38 seconds. So we can use this formula to find the value of sigma y squared. We have sigma x squared, 1,823. nx plus ny is the total number of runners, which we know is 50. And in part C, we found that the mean of the total number of runners is 8,54. So now we can put all of these values into our formula. So for sigma x squared, I'm going to say 1823, 0 plus sigma y squared, the value we're looking for, over 50 minus the total mean, 8,54 squared, is equal to the standard deviation, 1,38. Put this all under a root. To get sigma y squared by itself, let's square both sides. So to make it easier, I'm going to erase the root on this side. And because I'm squaring it, I square this side. Now let's move 8,54 to the right. I'm going to get 1823 plus sigma y squared over 50 is equal to 1,38 squared plus 8,54 squared. The next thing I need to do is multiply both sides by 50. So multiply by 50, which means I multiply both of these by 50 as well. So I'm just going to take out these 50s. Now to get sigma y squared by itself, all I need to do is move this value to the right. I'm going to get sigma of y squared is equal to my bracket 1,38 squared plus 8,54 squared, all multiplied by 50, minus 1,823. And I can put all of this straight into my calculator. 1,38 squared plus 8,54 squared. So multiply this by 50. Subtract 1,823 is equal to, the question wants our answer to one decimal place. Let's change it to decimals. And we get an answer of 1,918,8. Question 4 says, every Saturday, a particular community holds a puzzle event to raise money for a new leisure centre. Competitors attempt to solve a puzzle as quickly as possible. Last Saturday, 600 competitors took part. The times taken to complete the puzzles were normally distributed with mean 32,4 minutes and standard deviation 2,5 minutes. Part A says, how many competitors would you expect to have times within 1,2 minutes of the mean time? To find the number of competitors, we first need to find the probability that a competitor lies within the given restriction. We are working with normal distribution, but there are numerous ways that you can tackle this question. So normal distribution works with a bell curve. So let's start here. There's our bell curve. The mean lies directly in the middle. Let's put that in there. And we know that this is 32,4 minutes. The question tells us the competitors have times within 1,2 minutes of the mean. So if we add 1,2, we get 33,6. Let's make a line over here. But if we subtract 1,2, we get 31,2. Put a line over here. We are looking at competitors who lie between these two values over here. And you can find the probability that x is smaller than 33,6 and then subtract the probability that x is smaller than 31,2. And that will give you the section in here. But there is an easier way. Remember that the area under the bell curve is the total probability, 1. The mean is halfway. That means that all of this, I'm going to draw it in red, over here has a probability of 0,5. So if we can find the probability that x is smaller than 33,6 and we subtract the mean, we will get this section over here. Let's tidy this up a little bit. So to start, let's find the probability that x is smaller than 33,6. I'm going to make some space. We're working with normal distribution, so we're going to use the formula z is equal to x minus mu over the standard deviation. X is 33,6 minus mu, the mean, 32,4 over standard deviation, 2,5. Take your calculator. 33,6 minus 32,4 divided by 2,5 is equal to 0,48. This is our z-score. Z is equal to 0,48. Now, let's take our normal distribution table and find the probability. 0,48, and we get 0,6844. I can say the probability of z is equal to 0,6844. But I want to look at my diagram quickly. This gives us this whole section over here. But we only want a smaller section. We want the section in blue. We are looking at times within 1,2 minutes. That means that this side is equal to this side. So if we can find this section here, all we have to do in order to find our answer is double it. So to find this section, let's subtract the mean, 0,5. So I'm going to say 0,6844 minus 0,5 gives me 0,1844. Let's go back to our diagram. I want to clean it up again. 0,1844 is the probability that x is smaller than 33,6 but greater than the mean. But remember, these two areas are the same. So to find the total area between the blue lines, all we need to do now is multiply this by 2. I can multiply by 2, and I'm going to get 0,3688. This is our total probability. Now, to find the number of competitors, all we do is we multiply this by the total competitors, 600. Take your calculator, 0,688 multiplied by 600 is equal to 221,28. You cannot have a decimal of a person, so round off to the nearest whole number. And as our answer, we get 221. Part B says, in this Saturday's event, 60% of the competitors had times less than 36 minutes. 9 competitors who took part in Saturday's event are selected at random. Find the probability that at least 2 and fewer than 8 of these competitors had times less than 36 minutes. The words at least and fewer show us we are working with either binomial distribution or geometric distribution, but the question tells us that we have a total of 9 competitors. So we are working with binomial. So we can use the formula NCR multiplied by P with an exponent of R multiplied by Q with an exponent of N minus R. N is the total number of elements which in this case is our 9 competitors. So N is equal to 9. P is our probability, 60%. So P is equal to 0,6. Q is our complement, the probability that something does not happen. 1 minus 0,6 is 0,4. So Q is equal to 0,4. Now we need our X values. The question tells us we need to consider the probability of at least 2, but fewer than 8. That means that X has got to be greater than or equal to 2, but smaller than 8. We need to consider X values of 2, 3, 4, 5, 6, and 7. This is a large number of values that we need to work with. So to make it easier, we consider the alternative values, in this case 0, 1, 8, and 9, and then we subtract this from 1. So I can say that this is going to be equal to 1 minus the probability that X is equal to 0, 1, 8, and 9. And we can fill these values into R in our formula. So I'm going to say this is now equal to 1 minus, let's open a bracket. Let's start when X is 0. So I have 9C0 multiplied by 0,6 with an exponent of 0 multiplied by Q, 0,4 with an exponent of 9, plus, let's put 1 into our value, 9C1 multiplied by 0,6 with an exponent of 1 multiplied by 0,4 with an exponent of 8, plus, let's substitute 8 into our values. So we have 9C8 multiplied by 0,6 with an exponent of 8. I'm going to write it over here, multiplied by 0,4 plus 9C9 multiplied by 0,6 with an exponent of 9 multiplied by 0,4 with an exponent of 0. Now you can put each set of these into your calculator individually and find an answer with decimals, but you're going to find values with numerous decimals, and this can not only lead to error, but it is very time consuming. So an easier way to do this is to put this bracket into your calculator either as it is, but in this case I'm going to tidy this up a little bit. Remember that anything with an exponent of 0 is 1, and if you have NCR and R is 0, the entire value is 1. So now we have 1 minus, let's open a bracket, 9C0 is 1, 0,6 with an exponent of 0 is also 1, so this becomes 0,4 with an exponent of 9, plus, when you have an R value of 1, NCR becomes N, so this is 9 multiplied by 0,6 multiplied by 0,4 with an exponent of 8, plus 9C8 multiplied by 0,6 with an exponent of 8 multiplied by 0,4, plus, when you have an NCR and your N and R are the same values, NCR is 1. It becomes 1, so we can leave that, multiplied by 0,6 with an exponent of 9, 0,4 with an exponent of 0 is also 1, so we can leave that out as well. And now this is our bracket. So let's start by putting our bracket into our calculator. I have 0,4 with an exponent of 9 plus 9 multiplied by 0,6 multiplied by 0,4 with an exponent of 8 plus 9 multiplied by 0,6 with an exponent of 8 multiplied by 0,4 plus 0,6 with an exponent of 9 is equal to, we want to subtract this value from 1. So I can say 1 minus answer is equal to 0,9256. Leave your answer to 3 significant figures, and we get 0,926. Part C says 80 competitors who took part in the Saturday's event are selected at random. Use a suitable approximation to find the probability that more than 50 of these competitors had times less than 36 minutes. Use a suitable approximation. This tells us that we need to convert from binomial distribution to normal distribution. For normal distribution, we use the formula Z is equal to X minus mu over sigma. To find the mean, mu, we use NP, and to find sigma, the standard deviation, we use NPQ under a square root. In order to find these values, we first need N, P, and Q. The question tells us we are working with 80 competitors. So N is equal to 80. P is the probability. We already know that this is 60%. So P is equal to 0,6. And Q is equal to 0,4. Let's find the mean, mu, NP. So we can say 80 multiplied by 0,6. Take your calculator. 80 multiplied by 0,6 is equal to 48. That's our mean. To find sigma, standard deviation, we multiply this by Q and then we square root. We already know that NP is 48. So let's multiply this by Q, 0,4 is equal to 19,2. To make this easier, we can write this as 19,2 under a square root. We still need our value for X. And the question tells us we need to find the probability that more than 50 competitors. So X is 50. But please be careful here. We are using an approximation. If you need to find the probability that more than a value, we add 0,5 to X, which means in this case, X is 50,5. Now that with these values, we can find Z. Z is equal to 50,5 minus 48 over standard deviation, 19,2 under a square root. Take your calculator. 50,5 minus 48 divided by square root of 19,2 is equal to 0,5705. Round off to 3 significant figures, and we see that Z is equal to 0,571. With this, we can now find the probability. Take our table. We have 0,5, so start here. Column 7, this becomes 0,7157. I'm going to write this over here. 0,7157. But Z is 0,571. We need to account for this 1, which means we need to add 3 to our decimal. Let's add 3, and we get 0,716. Now let's take this value, and over here, I'm going to say the probability of Z is equal to 0,716. But remember, this is the probability that x is smaller than 50. So to find the probability that it's greater than 50, we say 1 minus 0,716. Take my calculator. 1 minus 0,716 is equal to 0,284 equals 0,284. And this is my answer. Question 5 says, in a group of 20 musicians, there are 9 guitarists, 6 pianists, and 5 drummers. 6 musicians are selected from these 20 to perform at a concert. Part A, find the number of different ways in which the 6 musicians can be selected if there must be at least 3 guitarists, at most 2 pianists, and exactly 1 drummer. The first question you have to ask yourself is, does arrangement matter? In this case, we have musicians at a concert. The order in which they stand has no relevance, so arrangement does not matter. So the only thing that we need to work with here is NCR. Let's start with the information we've been given. We have 9 guitarists, we have 6 pianists, and we have 5 drummers. This is the total number of musicians that we are working with. The question asks us to create a group of 6 musicians that includes at least 3 guitarists, at most 2 pianists, and exactly 1 drummer. And the best way to do this is to look at the possible combinations we could have. Our group has to have 1 drummer. So let's start there. Let's say D for drummer. At most 2 pianists. So we could have a group with 2 pianists. So let's say 2 pianists in this group, or 1 drummer and 1 pianist, or 1 drummer and no pianists. We have considered the drummers. We have considered the pianists. The only other thing we need to consider are the guitarists. The question says we have to have at least 3. That means that we can fill guitarists into our groups now. Let's start with our first group. We already have 3 musicians plus 3 guitarists. So we need to consider this as group 1. For the second group, we have 4 spaces. We can fill them with 4 guitarists. For the third group, we have 1 space taken up, which means we can fill in 5 guitarists. 3, 4, and 5. Now for each group, we need to consider the different musicians. In our first group, we have 1 drummer out of a total of 5. So this becomes 5C1. And, so we multiply, 2 pianists out of a total of 6. So this becomes 6C2. And 3 guitarists out of a total of 9. So 9C3. Now let's consider our second group. Again, 1 drummer out of a total of 5. 5C1. 1 pianist out of a total of 6. So this becomes 6C1. And 4 guitarists out of a total of 9. 9C4. Let's quickly do our last group. We only have 1 drummer. So 5C1. And 5 guitarists out of a total of 9. 9C5. Now we can quickly multiply these values together. Let's start with our first group. We have 5C1 multiplied by 6C2 multiplied by 9C3 is equal to 6,300. So 6,300. Let's look at our second group. again, we have 5C1 multiplied by 6C1 multiplied by 9C4 is equal to 3,780. And finally, our third group, 5C1 multiplied by 9C5 is equal to 630. Now we have three different groups. We could have group 1 or group 2 or group 3, which means to find our answer, we need to add these three values together. I already have 630. Let's add 6,300 and 3,780. Gives me a total of 10,710. Part B says 3 bands will be selected from the original group of 20 musicians. Each band will consist of 3 guitarists, 1 pianist, and 1 drummer. No musician can be in more than one band. The first band selected will play at a concert in France, the second band selected will play in Italy, and the third band selected will play in Spain. Find the number of different ways in which these 3 bands can be selected. Now, again, these are musicians in a band, so arrangement does not matter. The only thing we need to work with is N, C, R. But please be careful here. The question tells us that no musician can be in more than one band. This means that once a musician has been selected for a band, they cannot be selected again. So let's look at our musicians. We have 9 guitarists, we have 6 pianists, and we have 5 drummers. Each band has 3 guitarists, 1 pianist, and 1 drummer. The first band selected will play in France. So let's say that this is our band for France. We have 3 guitarists, we have 1 pianist, and 1 drummer. After that, the second band is selected, who will play in Italy. Again, 3 guitarists, 1 pianist, and 1 drummer. After that, the third band will be selected, who plays in Spain. 3 guitarists, 1 pianist, and 1 drummer. Let's start with the selections for the band going to France. We need 3 guitarists out of a total of 9. So we have 9 C3 and 1 pianist out of a total of 6. 6 C1 and 1 drummer out of a total of 5. So 5 C1. And now, because we are considering one band and another, we need to multiply our selections. We can multiply this, open a second bracket. For the band in France, we've already chosen 3 guitarists, which means now we are left with 6. We have chosen a pianist, which means we have 5 left, and we've chosen a drummer, which means we're left with 4. So to find 3 guitarists for Italy, we have a total of 6 to choose from. We can say 6 C3 and 1 pianist out of the 5 remaining, 5 C1, and 1 drummer out of the 4 remaining, 4 1. This is the band going to Italy. So before we move on to Spain, let's quickly just see how many musicians we still have to work with. We started with 9 guitarists, 3 went to France, 3 went to Italy, and we are left with 3. Of our pianists, we started with 6, 1 went to France, 1 went to Italy, and we're left with 4. Of our 5 drummers, 1 went to France, 1 went to Italy, and we're left with 3. These are the values we can use for our band for Spain. We need 3 guitarists out of the remaining 3, say 3C3 multiplied by 1 pianist from the 4 remaining, 4C1, and 1 drummer from the 3 remaining, 3C1. And now I can take my calculator and let's find the different selections. Let's start with France. I have 9C3 multiplied by 6C1 multiplied by 5C1 gives me 2,520. 2,520. We are multiplying these selections together. So let's multiply over here. And now we can find our second bracket. 6C3 multiplied by 5C1 multiplied by 4C1 is equal to 400. This is the number of selections for a band going to Italy. Now let's look at the band going to Spain. You can say 3C3 multiplied by 4C1 multiplied by 3C1 is equal to 12. Now to get our final answer, we multiply these values together. I already have 12, so let's multiply by 400, multiply by 2,520 is equal to 12,096,000. I can say 12,096,000. This is the total number of possible selections. Question 6 tells us that a bag contains 10 marbles, of which 4 are red and 6 are blue. 4 marbles are selected from the bag at random without replacement. The random variable x denotes the number of blue marbles selected. Part A says show that the probability that x is equal to 2 is equal to 3/7. Now, the first thing you need to notice is the word without replacement. This tells us we are working with dependent events. The random variable x denotes the number of blue marbles selected. So for this question, we need to find the probability that out of the 4 marbles drawn, only 2 are blue. And the best way to do this is to look at all possible combinations. So let's say that our first marble is blue. And let's say our second marble is blue. We already have 2, which means our third marble and our fourth marble have to be red. Let's say our first marble is blue, but our second one's red. Our third one is blue, and our fourth one is red. We could have a blue marble first, followed by a red marble, followed by another red marble, and our last marble is blue. But what if our first marble isn't blue? Let's say it's red, but our second marble is blue, and so is our third marble, but our fourth one is red. We can also consider a red marble first, a blue marble second, a red marble third, and a blue marble fourth. We have one more combination, a red marble first, a red marble second, a blue marble third, and a blue marble fourth. These are the 6 options that we can consider that contains 2 blue marbles. So now let's look at the probability. Remember, we're working without replacement, so these are dependent events. We have 6 blue marbles out of a total of 10. So if we draw a blue marble first, the probability is 6 out of 10. We do not replace the blue marble, which means the probability that our second marble is blue, we now have 5 out of a total of 9. We have 4 red marbles. We've removed 2, which means now we have 4 out of a total of 8. And for our last marble, also red, probability is 3 out of 7. Now let's look at our next option. A blue marble first, 6 out of 10. Remember, we are looking at one marble and another. This is why we're multiplying our probabilities together. The second marble is red, so we get 4 out of 9. And a blue marble third, this becomes 5 out of 8. And a red marble last, 3 out of 7. Let's look at our third option. A blue marble first, 6 out of 10. And a red marble second, 4 out of 9. And a red marble third, 3 out of 8. And a blue marble fourth, 5 out of 7. Let's look at our fourth option. A red marble first, 4 out of 10. And a blue marble, 6 out of 9. And another blue marble, 5 out of 8. And a red marble, 3 out of 7. Now, if you continue in this way, for every option, all 4 of your fractions will contain denominators 10, 9, 8, and 7, and numerators 6, 5, 4, and 3, but they may be in a different order. So to make this easier, we know that for all 6 options, we need to consider these 4 fractions. We can have option 1, or option 2, or option 3, or option 4, and so on, which means we need to now add these brackets together. But to make it easier, because we have 6 sets, we simply multiply the bracket by 6. Now I can take my calculator and I can say 6 out of 10 multiplied by 5 over 9 multiplied by 4 over 8 multiplied by 3 over 7 is equal to, multiply this by 6, and I get a fraction of 3 over 7. So I can say the probability that x is equal to 2 is 3 over 7. And we have now confirmed that this is true. Part B says draw up the probability distribution table for x. So let's start with our table. In our top row, in our first column, we can put in x. And in our second row, we say the probability that x is equal to x. We can close this bracket. The question tells us that x denotes the number of blue marbles. We are drawing 4 marbles from the bag. We can have no blue marbles, 1 blue marble, 2, 3, or all 4 marbles being blue. So the values of x that we need to consider are 0, 1, 2, 3, and 4. From part A, we already know that the probability of drawing 2 marbles is 3 over 7. Now to consider the other values of x. Let's start when we have no blue marbles, when x is 0. So let's make some space. If we draw no blue marbles, that means that all 4 marbles have to be red. So the first one's red, and the second, and the third, and the fourth. We have 4 red marbles out of a total of 10. So the first marble, 4 out of 10, then 3 out of 9, and 2 out of 8, and 1 out of 7. So take your calculator, 4 out of 10, multiplied by 3 out of 9, multiplied by 2 out of 8, multiplied by 1 over 7 is equal to 1 over 210. This is the probability of not drawing any blue marbles. So let's put this into our table. 1 over 210. A good way to tackle a question like this is to look at the simplest options first. So now that we've looked at no blue marbles, let's consider that all 4 marbles are blue. So if all 4 marbles are blue, with blue marble first, and second, and third, and fourth, we have 6 blue marbles out of 10. So we have 6 out of 10, and 5 out of 9, and 4 out of 8, and 3 out of 7. Take your calculator. 6 out of 10, and 5 out of 9, and 4 out of 8, and 3 out of 7 is equal to 1/14. This is the probability that all 4 marbles are blue. And I can put this into my table as well. Now let's look at the probability that we only draw 1 blue marble. So let's make some space. If we draw 1 blue marble, the other 3 are red. We could draw our blue marble first, followed by 3 red, or we could have red first, then a blue marble, red first and second, but our third marble's blue, or a red marble, another red marble, a third red marble, followed by a blue marble. So let's look at the probabilities of this. We have 6 blue marbles out of 10, so we have 6 out of 10, and 4 red becomes 4 out of 9, and 3 out of 8, and 2 out of 7. Let's look at our second option. 4 red marbles out of 10, and we still have all 6 blue marbles, 6 out of 9, and 3 out of 8, and 2 out of 7. Let's see what happens if our third marble is blue. First marble's red, so 4 out of 10, and second marble's red, 3 out of 9, and we have all blue marbles in the bag, so this is 6 out of 7, 6 out of 8, and 2 out of 7. Let's look at our last combination. First marble's red, 4 out of 10, and second marble's red, 3 out of 9, and third marble's red, 2 out of 8, and our fourth marble is blue, 6 out of 7. Now for all 4 combinations, the denominators of all of our fractions are 10, 9, 8, and 7. The numerators are 6, 4, 3, and 2. So to make this easier, we can multiply the fractions in this bracket and then multiply the bracket by 4. So we account for the 4 options. So I'm going to take my calculator. I'm going to say 6 out of 10 multiplied 4 out of 9 multiplied by 3 over 8 multiplied by 2 over 7, and we multiply all of this by 4, and I get 4 over 35. So now I can put this into my table as well. 4 over 35. Now you can do the same thing for 3 blue marbles, but please remember that when working with a distribution table, if we add all of these values together, we get an answer of 1. So to find the probability that x is 3, we can subtract our known probabilities from 1. So let's do this now. Take my calculator. I'm going to say 1 minus 1 over 210 minus 4 over 35 minus 3 over 7 minus 1 over 14 is equal to 8 over 21. I can put this in here. And I've now completed my distribution table. Part C says find the probability that at least 2 of the marbles chosen are blue, given that at least 1 red marble and at least 1 blue marble are chosen. The word given shows us that we are working with conditional probability. And when doing this, we can use the formula probability of B given A is equal to probability of B and A over the probability of A. In this case, we have the probability of at least 2 blue marbles. So let's say 2 blue, given at least 1 red marble and 1 blue marble, 1 red and 1 blue. So this is equal to probability of 2 blue marbles and 1 red marble and 1 blue marble, all over probability of 1 red marble and 1 blue marble. When working with conditional probability, it is always a good idea to start with the value in the denominator of your fraction. So in this case, let's find the probability that at least 1 marble is red and 1 marble is blue. Always keep in mind that statistics is realistic. It is a real life situation. And in this question, we have been looking at the possible number of blue marbles. And we looked at no blue marbles, 1, 2, 3, and all 4 blue marbles. In this question, we need to consider at least 1 red marble and at least 1 blue marble. If there is at least 1 blue marble, we cannot have 0 marbles. If we have at least 1 red marble, we cannot have all 4 marbles that are blue. This means that if at least 1 marble is red and at least 1 blue marble, we can have 1 blue marble or 2 blue marbles or 3 blue marbles. For this question, we can use our answer from part B to help us. So let's quickly look at our distribution table. We've already found the probability of 1 blue marble, 2 blue marbles, and 3 blue marbles. So to find the probability, let's write this over here, of at least 1 red marble and at least 1 blue marble, all we need to do is add these 3 probabilities together. So I'm going to take my calculator, 4 over 35 plus 3 over 7 plus 8 over 21 is equal to 97 over 105. I'm going to make a note of this as well over here. 97 over 105. This is the probability of at least 1 red marble and 1 blue marble. Now we need to consider the probability of at least 2 blue marbles and at least 1 red marble and 1 blue marble. We can consider the different number of possible blue marbles to help us. We know that we cannot use 0 blue marbles and we cannot use 4 blue marbles. But if you have 1, 2, or 3 blue marbles, we have at least 1 blue and at least 1 red. But now we also need to consider at least 2 blue marbles. If we have at least 2, we have 2 blue marbles or 3 blue marbles. So these are the probabilities we need to consider. So let's have a look at our distribution table. Probability of 2 blue marbles, 3 over 7. Probability of 3 blue marbles, 8 over 21. We need to add these together. So I can say 3 over 7 plus 8 over 21 is equal to 17 over 21. This is the probability of at least 2 blue marbles and at least 1 red and 1 blue. Now that I have my fractions, I can fill in my answer. So I'm going to tidy this up. And now I can say that this is equal to 17 over 21 over 97 over 105. Take my calculator. Let's create a fraction. 17 over 21 over 97 over 105 is equal to 85 over 97. Let's make it a decimal. 0,8762. Round off to 3 decimal places. And I get my final answer is 0,876.